going to be talking about how to solve quadratics by factoring. Now, today's big mumbo jumbo is being able to solve by factoring, which is why we needed to take the time to review how to factor. Now, we are going to solve by factoring when we see two x's, meaning we're going to see an x squared and we're going to see at least a bx. We might see a c, we might not, but nonetheless, we are definitely going to see two terms and both terms contain some form of x. In order for us to factor, it does need to be equal to 0. That is the most important piece. Once we have it equal to 0, we will factor. Then the last step is you're going to set each of your factors and solve for x. So we're going to talk about what it is and how we solve for x, because this is the first time that we're no longer looking at a multiplication problem. We are taking our factors, our bubbles, we're setting those equal to 0 because that's called the zero product property, and we will take each factor and set it equal to 0 to solve for x. So let's review the zero product property. So it's saying if you're multiplying any two terms, and it doesn't matter the two terms, but if you're multiplying any two terms and your answer is 0, then either A was 0, because 0 times anything is 0, or B could be 0. Anything times 0 is 0. And big picture, both A and B would be 0, because 0 times 0 is 0. So the zero product property, ideally, another solution to quadratics is calling it zeros. So once you factor, and you set your factors equal to 0 to solve for x, you have now found your x-intercepts. So let's kind of go and practice. If one of our factors was 3x and we set it equal to 0, we'd have to solve for x. 3 is being multiplied to x. We divide 3 on both sides. X equals 0 divided by 3. As long as 0 is in the numerator, 0 divided by anything is 0. So our solution would just be x equals 0. Now, our second example, we have 3 times x plus 2. Now, we could set 3 equal to 0, but if you notice, there's no variable to solve for. So anytime you have a GCF that doesn't contain a variable, you can't really solve it because there's nothing to solve for. And 3 is actually not equal to 0. It's actually an untrue statement. So a plain GCF without a variable is a waste of time. But x plus 2, set that equal to 0, there is a variable to solve for, and we will. We would subtract 2 from both sides, x equals -2, and that would be our solution. Now, x plus 3 times x plus 2, this is what we're usually seeing when we factor. We see some sort of multiplication problem, and each factor does contain a variable. So we have to set each factor, each group, equal to 0 and solve for x. So x plus 3 equals 0 and x plus 2 equals 0, and solve each of them separately for x. So we'd subtract 3 from both sides. X equals -3 would be one of our solutions. Subtract 2 from both sides to solve for x. X equals -2. So then we would receive the other answer. So we would receive 2 solutions. So here are our steps for solving quadratics by factoring. So first thing, make sure that the equation is in standard form. Again, what does it mean to be in standard form? It goes in descending order, high to low. Ax squared, biggest variable first, then bx in the middle, then our constant, no variable. So it works from high to none, high to low, highest variable, middle, no variable. And it has to be equal to 0. Legitimately, it has to be equal to 0. Now, solving by factoring, we do need to make sure of, because this is saving us for the future, always make x squared positive. It is going to make your life easier. Trying to factor with negatives is just frustrating. And when we're solving, we can move x squared to any side of the equals that we can make it positive. Might be a little bit more work, but it's going to save us in the long run. Factor completely. So once it's equal to 0, x squared is positive. Factor. That's either by GCF, that's by easy factoring, what multiplies to C that adds to B, which I call double bubble, easy factoring. Or it could be when A is involved, when we have a leading coefficient, we're going to have to go through more steps how to factor. That could be, the ways that I show it is using the box method or factor by grouping. Once you do that, you're going to make an equation for each factor, set it equal to 0, so like we just did reviewing the zero product property, and then you'll solve each equation for the variable. You'll solve each of them for x. Remember, when you are solving quadratics, the word solution, the word zeros, the words x-intercepts, answers are all the same thing. We're ideally finding the x-intercepts without graphing, and that's kind of all the other methods are used for. still the x-intercept, still the solution, we just don't have it graphically. So finding roots, that's another word that we can use to represent solutions. The word root is ideally just the x-intercepts. Now, what differs us in this equation, our equation is f of x equals x squared minus 8x. Well, it says our first thing that it has to be equal to 0. Well, there's no way to equal it to 0. First off, remember f of x is equal to y. So when we are asked to find a root, a solution, x-intercepts, zeros, take your f of x, so take f of x or y, and replace that with 0. So 0 equals x squared minus 8x. Now it automatically is already equal to 0. Now for those of you, some do not like the 0 on the other side, so if you need to flip it around and do x squared minus 8x equals 0, please know that that is totally an option as well. We see two different terms and both of them contain an x, which tells us we need to attempt factoring. If we look at it, when we have just two terms, or nonetheless, the first step in factoring is finding the GCF. If I look at x squared minus 8x, I notice that they both contain a variable of x. So I'm going to divide out the GCF, and I'm going to bring the GCF out, x. And then we have x squared divided by x. If we have two of them and we divided one away, we took it away, we have one left, x. Negative 8x divided by x, the x's cancel, and we're left with minus 8. Now this is equal to 0, and what takes us further than just factoring is we do need to solve for x. So we're going to take each of these factors, x, set it equal to 0, set x minus 8 equal to 0, and solve for x. Our first factor is already solved for. X equals 0 is one of our solutions. Minus 8, we'd add 8 to both sides, and our other answer would be x equals 8. Now, what does this represent? Graphically, if we wanted to go and graph it, we would find that they would have two x-intercepts without even graphing it. They would have an x-intercept at 0 and an x-intercept at 8. And it is a positive x squared, so this graph would be going up. So without even graphing it, I can create the graph that would give me a good picture of what is happening. Solve the quadratic equation by factoring completely. So this does not have y equals or f of x. This one has x squared minus 12x equals 3x squared. So this is ideally setting us up. We need to set it equal to 0. Now here's what's different with this one. I notice that we have the same two types of variables here. We have an x squared on the left and we have a 3x squared on the right. Now, I always want my x squared to be positive. So what we need to do is we need to move one of these to the other side. We always want to move towards the bigger positive x squared. So 3x squared is bigger, so I'm going to move the positive x squared on the left side over by subtracting. So I'd have negative 12x equals 3x squared minus 1x squared is 2x squared. Now we still need to get it equal to 0, which means we need to continue to move things over. So I need to move the negative 12x over by adding 12x, and now I get 0 equals 2x squared plus 12x. And again, I do see that I have two terms. Now with these two terms, we need to look for, our first step for any type of factoring is a GCF. Start with your numbers, 2 and 12. What can I divide both 2 and 12 by? Both of them are divisible by 2. Well, I also notice that they both have a variable, which is important. That's how we know we will always factor, is if we see two sets of variables. If I have x squared and I have x, the most I can take away, to be fair, would just be a single x. So our GCF is 2x. It comes out in front, 2x, divide it. 2 divided by 2 cancels. X squared means you have two of them, but you took one away, so I'm just left with x. 12 divided by 2 is 6, but x divided by x cancels, so it's just left alone. And so now what we're going to do is we're going to take our GCF. It looks like a multiplication problem, 2x times x plus 6. But to actually solve, we need to set each factor equal to 0 and solve for x. So 2x equals 0, x plus 6 equals 0. So we're finding our solutions, the x-intercepts, without graphing. 2 is being multiplied to x, so we divide by 2. X equals 0 divided by anything is 0, so one of our solutions is x. X plus 6 equals 0, we'd subtract 6 to both sides. X equals negative 6. So this had two real solutions because I found legitimately two solutions. Solve the quadratic equation by factoring. So our first step, x squared minus 4x equals 45. So this is straight away, it's set up that we just need to equal it to 0. My x squared is already positive, so we don't have to worry about moving our left side. What we want to move is the fact that we don't want a 45. It needs to be 0 over here. So we're going to undo that by subtracting. We have x squared. We cannot combine because these are not like terms, and we want it in descending order. Biggest variable, middle variable, constant without a variable, and now it is equal to 0. Now what we have here is what's called a trinomial, and when we have a trinomial and their a value is 1, we can go ahead and do our easy factoring. What multiplies to c? Negative 45, a, b, c. That adds to negative 4. So all the ways to get to 45. 1 and 45, 3, 15, 5, and 9. And I believe that is it. I believe so. Other than that, I can certainly find what one's going to give us to 4. Well, 1 and 45 is way too big. That's not going to be 4. 3 and 15, if we think subtraction, that's still 12, a little too big. But 5 and 9 is going to get us to negative 4. 5 and 9, and the rule is it keeps the sign of the bigger number. So since we're getting to a negative 4, that means my bigger number is. So here are my two factors. When a is just 1, it goes right into double bubble. X into each. 5 is positive, x plus 5, minus 9, x minus 9, equals 0. So we created the multiplication. Now set each factor equal to 0 and solve for x. So x plus 5 equal to 0, we'd subtract 5. X equals negative 5. X minus 9 equals 0. We'd add 9 to both sides. X equals 9. And there would be our answers. We see this setup again. We see f of x. Now it says find the zeros. Same as before when we had roots. When we see f of x, that's what we are changing. We automatically can jump right into changing f of x or y into 0. So 0 equals 2x squared minus 11x plus 12. Now, there's no GCF here, but we do have a leading coefficient. When we have an a value, a, b, c, we have to multiply our a and c together. So what multiplies 2 times 12 is 24. That adds, our b still stays our middle, negative 11. So all the ways to get to 24, 1 and 24, 2 and 12, 3 and 8, and 6 and 4. Now, the only way to multiply to a positive but add to a negative is both of them are negative. So knowing that, we're looking that truly does add. 1 and 24 would be 25. 2 and 12 would be 14. 3 and 8, 8, 9, 10, 11. There it is. So it'd be negative 3 and negative 8 to multiply to a positive 24, but add to a negative 11. Now I'm going to show this by doing the box method. Your ax squared always goes in the top left. 2x squared goes here. C always goes in the bottom right. Then your two numbers, negative 3 and negative 8, get thrown in the diagonals, but give them an x. So negative 3x and negative 8x. Now I'm going to find the GCF of every row and every column. So 2x squared minus 8x, it leads with the positive. 2 and 8 divisible by 2, x squared and x both have an x. Negative 3x and 12, negative 3x leads my box, so I'm going to take out a negative. Negative 3 and 12, they both can be divided by 3. Go into my first row, 2x squared and 3x. 2 and 3 have nothing in common, but they both at least have an x, and 2 is positive, so it's a positive x. Negative 8x and 12, it leads with the negative, so I'm going to take out a negative. 8 and 12 are both divisible by 4. So our two factors would be 2x minus 3, 2x minus 3 times x minus 4 equals 0. Now we have to finish solving. Before we would finish off and leave it at multiplication, but we're asked to solve, we set each factor equal to 0. Whoopsies. 2x minus 3 equals 0. I'd add 3 to both sides. 2x equals 3. Divide by 2. X equals 3 halves. I do know the decimal for 3 halves ends up being 1.5, which is okay. If you ever get a decimal that is ugly, that is repeating, that never stops, we do not want to use it. X minus 4, set that equal to 0. We'd add 4 to both sides. X equals 4 would be our other solution. So we received 3 halves, or 1.5, because that stopped and was beautiful, and x equals 4. Now for my students who might have enjoyed doing factor by grouping, what I did here was I split up the negative 11x using the negative 8x and the negative 3x that we found to work. I found the GCF of the first group, 2x, so I took it out. I found the GCF of the second group, negative 3. I took it out. My factors matched, x minus 4, x minus 4. That's one of my answers. Then I took the GCF of 2x and I took the GCF of negative 3 and I brought it together to get 2x minus 3. Now I end up having the same factors. Our next step from here would just to be go and solve each factor equal to 0 and solve for x. We would get the same answers as we did before.